Deep beneath the surface of our world, buried in rocks older than time itself, lies a secret that has slept for billions of years. Invisible, silent, and unassuming, it waits patiently, holding within it a power unimaginable. 1 gram of this mineral contains the energy of thousands of tons of conventional fuel. One small spark, one split atom, and it can illuminate a city or obliterate it. This is uranium, forged in the hearts of dying stars, hurled across the cosmos, and settled into the earth long before humans walked its surface. Uranium has witnessed the birth of planets, the rise of life, and the slow, relentless march of time. For centuries, it remained a quiet curiosity, a mineral among many. Scientists examined it, measured it, and cataloged it, never suspecting the force it contained at the core of its atoms. But when humanity finally unlocked its secrets, the world changed forever. Laboratories became arenas of both wonder and fear. The atom split. An energy that once burned only in stars now surged through human hands. Cities would shine with its power, but nations would tremble under its threat. Uranium carries a story of ambition, discovery, and danger, one that intertwines the destiny of the universe with the fate of humankind. Tonight, we will follow the journey of this extraordinary element, from the shadowy mountains of Saxony to the secret laboratories of the modern age. We will witness its quiet beginnings, its violent potential, and the choices humanity must face when confronted with a force older than the Earth itself. This is the story of uranium, the mineral that changed everything, the power that could create, and the danger that could destroy. Long before the first humans set foot on the lands we now call nations, long before civilizations carved stone and drew maps of the heavens, the Earth itself held secrets. Deep within its crust, hidden from the eyes of the curious, lay elements that had formed in the earliest fires of the universe. Among these elements was one that seemed ordinary at first glance, a heavy, dark mineral that whispered only to those patient enough to listen. Its story had not yet been told, yet it carried within it the potential to illuminate and destroy, to heal and harm, to change the course of human history. This was uranium. In 1789, in a small corner of the Kingdom of Prussia, a chemist named Martin Heinrich Klaproth encountered this strange substance. Miners had brought him samples from the silver-rich deposits of the Erzgebirge, the mountains of Saxony. Klaproth noticed its weight, heavier than anything he had handled before, and the faint greenish tint of its powdered form. He tested it, measured it, and examined it with the meticulous care of a scientist driven by curiosity rather than ambition. When he announced his discovery to the world, he named the element uranium, after the newly discovered planet Uranus, which had only recently appeared in the night sky, far above the heads of ordinary people unaware of its celestial dance. The name itself hinted at the mystery, the connection between the heavens and the earth, a silent acknowledgement that this mineral held a story that transcended the ordinary. At the time, uranium seemed inert, harmless, a curiosity for chemists who cataloged the treasures of the natural world. Its true power lay hidden, locked deep within its atoms, invisible to the naked eye and unimaginable to the human mind. Yet even in its quiet state, uranium possessed a strange aura. When powdered, it glimmered faintly under certain lights, as though it were trying to communicate, to hint at the immense energy lying dormant within its structure. For decades, it remained just that, a mineral, a curiosity, a footnote in the annals of scientific discovery. People passed it by, unaware of the destiny it carried in its atomic heart. The Earth had shaped uranium over billions of years. It was born in the cores of exploding stars, forged in nuclear furnaces that existed long before humans walked the Earth. Each atom had endured the chaos of supernovae, traveling across the cosmos before settling into the crust of a planet that would one day be called Earth. In this sense, uranium was a relic of the universe's earliest fires, a cosmic messenger containing the whispers of stars and the memory of creation itself. It was a reminder that the world beneath our feet was older and more powerful than the civilizations that had risen and fallen above it. For those who first studied it, uranium was a puzzle. Its density, its chemical properties, its faint glow, all suggested something unusual, something that defied the simple laws that governed ordinary minerals. Yet it did not scream of danger. It did not reveal itself readily. It waited, patient, for humanity to grow in curiosity, for minds to sharpen in the pursuit of understanding, and for the dawn of an age when atoms could be seen not just as components of matter, but as vessels of unimaginable energy. Klaproth could not have known, as he held the black mineral in his hands, that his discovery would one day light the cities of the world and also cast shadows of destruction over entire nations. The centuries that followed saw uranium quietly weave itself into human thought. It became a subject of study, a point of fascination for chemists and alchemists who sought to understand the natural world in its entirety. It was during this period that the world began to realize that some elements were not merely passive, inert substances. They could act, change, transform, and in doing so, they hinted at deeper truths about the universe. Uranium was one of the first elements to whisper these truths, to suggest that the universe was not simply a collection of matter, but a web of energy, potential, and invisible forces that governed everything from the smallest particle to the largest galaxy. Even as the Industrial Revolution surged forward, bringing light and power to cities, uranium remained largely unknown outside the walls of scientific laboratories. Its potential lay dormant, unrecognized, waiting for a mind capable of seeing beyond the immediate, beyond the tangible. The Earth had created this element not for immediate consumption, but as a guardian of secrets, a challenge to those who sought knowledge with humility and patience. It was a silent companion to humanity's growth, a reminder that even the smallest, heaviest rocks could carry the weight of history within them. As night falls over the Ore Mountains, where Klaproth first discovered uranium, one can imagine the faint trace of its greenish powder glowing softly in the candlelight of a curious scientist's lab. Perhaps at that moment, the world took a tiny, almost imperceptible step toward a future that would be defined by energy, by power, and by consequences that no one could yet fathom. Uranium, hidden in the folds of the earth, was waiting to tell its story, waiting for humanity to listen, to dare, and to unlock the invisible forces that had shaped the cosmos itself. It is remarkable, when we look back, how something so small, so seemingly insignificant, could hold within it the power to illuminate entire cities, to reveal the secrets of the atom, and to change the course of history forever. Uranium is a testament to patience, to curiosity, to the understanding that not all power is immediate, not all knowledge is obvious, and that the Earth, in its slow and deliberate ways, carries treasures far beyond what the eye can see. It is a story of the hidden, a narrative of the unseen forces that govern life and matter, waiting for the brave, the patient, and the curious to discover them. In the stillness of the laboratory, with the mineral resting quietly on a wooden table, it is impossible to imagine what the next century would bring. The whispers of uranium would grow louder. They would reach the ears of the greatest minds in science, drawing them into experiments that would illuminate the atom, reveal the power of nuclear fission, and unleash energy that had previously been confined to the cores of stars. From a dark, heavy mineral in the mountains of Saxony, uranium would become a central actor in a story of creation and destruction, of light and shadow, of human ambition and cosmic mystery. The unknown is where stories begin, and the story of uranium is no exception. From its quiet beginnings, it promised a journey that would take humanity from the curious observations of one chemist in the 18th century to the most profound ethical dilemmas of the modern world. Its path was hidden, its power latent, but even then, in the soft glow of candlelight over greenish powder, the Earth had already set the stage for a tale of wonder, of danger, and of transformation. Uranium waited, patient and eternal, for those willing to listen, willing to learn, and willing to bear the weight of the knowledge it carried. For centuries, uranium lay in quiet obscurity, a heavy mineral whose secrets remained locked in its dense atoms. Scientists handled it with curiosity and caution, measuring, weighing, and observing, yet it offered no obvious revelations. It was a silent witness to the passage of time, imperceptibly changing while human hands and minds pursued knowledge, unaware that the Earth itself had embedded within uranium a message written in the language of atoms and energy. The story of uranium's awakening began in the final years of the 19th century, a period when humanity's understanding of matter was about to take a dramatic leap. In 1896, Henri Becquerel, a French physicist, was exploring the relationship between sunlight and phosphorescent minerals. His experiments were methodical, careful, and seemingly routine. He wrapped photographic plates in black paper and placed them alongside minerals, expecting light to leave its mark. What he observed instead defied expectations. Uranium salts, even without exposure to sunlight, blackened the plates. The energy came not from the external world, but from the element itself. For the first time, a human mind had witnessed radioactivity, an invisible force emanating from the heart of the atom. It was as if uranium were speaking, whispering across time and space to reveal a hidden power. The scientific community was stunned. This was not a light, a chemical reaction, or a simple glow. This was something deeper, something inherent to the mineral, a fundamental energy that existed at the very core of matter. Becquerel's discovery opened a door that no one could ignore, a door that would soon lead humanity into the heart of the atom. Following this revelation, two extraordinary scientists began a journey that would define modern physics and chemistry. Marie Curie and her husband Pierre Curie became entranced by the mysteries of radioactive substances. From the soil and rocks of Europe, they painstakingly extracted and purified uranium and other radioactive materials. They discovered polonium and radium, names that would be remembered for centuries. Yet through it all, uranium remained the constant, the original element whose energy seemed boundless and eternal. Their experiments were relentless, often dangerous, yet filled with a sense of wonder. They measured, weighed, and observed the emissions of radioactive elements, noting their invisible power. Marie Curie's hands, delicate yet unyielding, sifted through tons of mineral ores, seeking the faintest traces of radioactive light. Every observation brought them closer to understanding the laws that governed the atom, and every discovery revealed that the world of matter was far more dynamic and alive than anyone had ever imagined. At the same time, theoretical physicists were beginning to map the unseen world within atoms. Scientists like Ernest Rutherford and Niels Bohr explored the architecture of matter, suggesting that atoms were not indivisible, as once thought, but contained a complex structure of electrons, protons, and neutrons. Uranium, with its dense nucleus, became a natural focus. It was heavy, energetic, and mysterious, a puzzle piece in the grand architecture of the universe. As the Curies and their contemporaries conducted experiments, the public remained largely unaware of the significance of these discoveries. Uranium was still a laboratory curiosity, a strange mineral whose energy could blacken a photographic plate or create faint glows in isolation. Yet, beneath the calm surface of these early studies, the stage was being set for something monumental. The experiments of the late 19th and early 20th centuries were the prelude to a revolution in human understanding, a revolution that would transform the way humanity viewed energy, matter, and even life itself. Uranium's energy was unlike any other. It was silent, constant, and inexorable, flowing from the nucleus of each atom with a force that seemed infinite. The element did not merely react. It radiated, a persistent signal from the depths of the earth, a reminder that within the smallest pieces of matter lay extraordinary potential. The experiments of Becquerel and the Curies were not merely scientific studies. They were conversations with the universe, attempts to understand the language of energy and matter, to decode the hidden rules that governed existence itself. The process was painstaking. Tons of ore were crushed and dissolved. Filtrations and precipitations, chemical separations, and measurements consumed years of labor. Marie Curie often worked late into the night, in a lab lit only by lamps, surrounded by the glowing powders that fascinated and terrified her. Yet the glow of uranium was not just a physical phenomenon. It was a metaphor, a symbol of the unknown waiting to be illuminated by human curiosity. Each measurement, each observation, brought them closer to understanding the atom, and each step revealed that uranium was no ordinary element. It was a vessel of energy that mirrored the stars themselves, a reminder that the universe was not static, but dynamic, radiant, and alive. The experiments also revealed uranium's complexity. Its radioactivity was relentless, a constant emission of energy that could not be turned off or contained indefinitely. This invisible force fascinated scientists, yet it also hinted at danger. Nature had embedded within uranium a potential that was not inherently evil, nor inherently good. Its power depended entirely on how humans would wield it, and the experiments of the late 19th century were the first steps in understanding both its promise and its peril. By the time the first decades of the 20th century approached, uranium had transformed from a mere mineral to a symbol of human curiosity, ambition, and potential. It had gone from the quiet rock in Saxony to the focus of laboratories across Europe. Scientists now knew that the energy within its atoms was real, measurable, and powerful. They could detect it, study it, and begin to imagine the consequences of harnessing it. Each experiment was a brushstroke in a vast painting, illustrating the energy hidden in the universe, waiting for the human mind to discover, understand, and perhaps, someday, control it. Uranium's story during this period is a testament to the power of observation, patience, and relentless curiosity. It shows how humanity can approach the unknown not with fear, but with wonder. The mineral that once lay hidden in the earth had revealed the first hints of its profound nature. It was no longer just a curiosity. It was a key to understanding the fundamental structure of matter, the forces that bind the universe, and the potential energies that could reshape life on Earth. The experiments of Becquerel, Curie, and their contemporaries were more than scientific achievements. They were acts of imagination, courage, and dialogue with the invisible. They were the first to listen to the whispers of uranium, to recognize that within a single atom lay stories older than humanity, older than the Earth, older than the stars themselves. Uranium was teaching humanity to see beyond the visible, to sense the hidden forces of the cosmos, and to understand that the smallest particles could contain the greatest powers. And yet, even as the glow of uranium illuminated the minds of scientists, the world outside their laboratories remained unaware. Few could grasp that this mineral, silent for billions of years, would soon influence wars, energy, politics, and the ethical dilemmas of modern civilization. The experiments were the first chapter in a story that would grow larger and darker, brighter and more illuminating, as humanity stepped into the age of the atom. Uranium, patient and eternal, waited for the next explorers, the next dreamers, to uncover the full extent of its power, to take the next step from curiosity to revelation. The experiments of the late 19th and early 20th centuries had awakened humanity to the hidden energy within uranium. Scientists had glimpsed the glow, measured the emissions, and marveled at the silent power residing in each atom. Yet, for decades, the full extent of this energy remained elusive. Uranium's potential was like a locked door. Brilliant minds had found the key, but they had yet to turn it. The true revelation was still to come, and it would arrive with the quiet intensity of a storm building far out at sea. In the 1930s, the world of physics was transforming. The atom was no longer a simple particle, indivisible and inert. It had a nucleus, dense and potent, capable of forces that could rival the energy of the stars. Scientists in Europe were racing to understand the nature of this nucleus. Lise Meitner, a brilliant physicist working in Germany, and her collaborator Otto Hahn were probing the mysteries of heavy elements. Their curiosity was insatiable, their work meticulous, their minds attuned to the subtle signals of the atomic world. Uranium, the element discovered centuries earlier in the quiet mountains of Saxony, became their focus, a puzzle whose solution would alter history forever. In December 1938, a quiet laboratory in Berlin became the stage for one of the most profound discoveries in human history. Otto Hahn and Fritz Strassmann were experimenting with uranium, bombarding it with neutrons, observing the changes in its structure. The element, once thought stable and unchanging, began to behave in ways that defied expectation. Hahn detected the presence of lighter elements forming where none should have been. Something extraordinary had occurred. The uranium nucleus had split. The atom, the building block of matter, had been divided. This was nuclear fission, a phenomenon that released energy of a magnitude previously unimaginable. Lise Meitner, exiled in Sweden due to the growing dangers of war, examined the data and grasped the full meaning. The splitting of the uranium atom was not a minor chemical reaction. It was the liberation of energy stored within the nucleus itself, energy that mirrored the forces of the sun and stars. A single gram of uranium, she realized, could release more energy than tons of coal or oil. It was a silent power, invisible and latent, waiting for the human mind to discover it and for hands to direct it. The revelation was both exhilarating and terrifying. Humanity had unlocked a force that was older than the Earth, older than civilization, older than memory itself. The same energy that had formed the elements in exploding stars was now accessible in the laboratories of Europe. The excitement among scientists was palpable. They were witnessing the birth of a new age, one in which energy could be released in ways that had previously been confined to the heavens. Yet this revelation carried with it a shadow. The same power that could illuminate cities and fuel industry could also annihilate them. The split of the uranium nucleus was not merely a scientific achievement. It was a paradigm shift with profound ethical and political implications. The potential for creation and destruction were intertwined, inseparable. Uranium had whispered to humanity for centuries, but now it spoke with a voice that demanded attention, caution, and reflection. Scientists began to explore the chain reactions that fission could produce. If one uranium nucleus could split and release energy, could this trigger other nuclei to split, creating a cascading explosion of unimaginable power? The mathematics confirmed the terrifying truth. It was possible. In the right conditions, uranium could release energy in a fraction of a second equivalent to the total output of cities, forests, and even small nations. The atom, once thought a symbol of stability, was now a potential harbinger of both progress and devastation. Across Europe and beyond, governments began to take notice. The revelation of uranium's power could not remain confined to the pages of scientific journals. The knowledge had implications for war, for energy, for the very survival of humanity. Secret programs were launched, physicists were recruited, and laboratories transformed into arenas where science, ambition, and geopolitics intersected. Uranium was no longer just a mineral. It was a key to a future that balanced on the edge of promise and peril. The personal lives of the scientists involved were deeply intertwined with this discovery. Lise Meitner, despite the political dangers and personal exile, remained dedicated to understanding the nature of fission. Otto Hahn and Fritz Strassmann, working in a world edging toward war, continued their experiments with a mix of awe and trepidation. The atomic revelations were not just technical achievements. They were profound encounters with forces that had existed since the birth of the universe. Every split of a nucleus echoed the explosions of distant stars, reminding humanity that the universe itself was alive with energy, and that we were only beginning to comprehend our place within it. The cinematic drama of discovery unfolded not just in laboratories, but also in the imagination of the world. The idea that a tiny mineral could contain energy equivalent to 1,000 suns captured the minds of writers, scientists, and visionaries alike. Uranium was no longer a curiosity. It was a messenger, a symbol of the duality of human ambition, our desire to illuminate and our capacity to destroy. The experiments of the late 1930s marked a turning point, a revelation that combined the poetry of the cosmos with the stark realities of human potential. By the end of 1938, the world had glimpsed the ultimate secret hidden in uranium. The atom had been divided, the nucleus unleashed, and humanity confronted with a force both magnificent and terrifying. It was a moment that demanded reflection, not just in scientific terms, but in philosophical and ethical ones. What does it mean to hold such power? How should humanity wield a force that can sustain life or extinguish it in an instant? The revelation of nuclear fission was not merely an achievement. It was a challenge, a question posed by the universe itself to those willing to listen. As the first chain reactions were theorized, the world stood at the threshold of an age defined by energy, conflict, and consequence. Uranium, which had lain hidden for billions of years, had finally spoken in a language humanity could understand. Its voice carried a warning as well as an invitation. It called upon the human mind to explore responsibly, to wield knowledge with wisdom, and to remember that within the tiniest particles of matter lay forces that had shaped the cosmos long before our species had emerged. The revelation of the atom's division marked the beginning of a new epoch. It was a moment of awe, of dread, and of unbounded curiosity. Scientists had unlocked a secret older than the Earth itself, a secret that could illuminate cities, cure diseases, power industries, and yet also obliterate civilizations. Uranium, once a silent mineral in the mountains of Saxony, had become a beacon and a warning. Its energy was no longer hidden. It was now a presence in human history, a force that demanded respect, understanding, and careful consideration. In this moment, the story of uranium transitioned from the quiet curiosity of chemists to the dramatic reality of a world on the brink of transformation. The element that had whispered through centuries had now shouted through the heart of the atom, and humanity was listening, poised between wonder and fear, ready to step into a future defined by the extraordinary energy it had finally unlocked. The revelation of uranium's power was not confined to laboratories or scientific journals. The world had awakened to a new force, one that could illuminate cities, revolutionize industry, and reshape the very structure of human civilization. But alongside this promise came an undeniable shadow. The energy hidden in uranium was a double-edged sword, capable of creation and annihilation alike. Humanity was entering an era where knowledge itself became a weapon, and the consequences of discovery could no longer remain abstract. By the late 1930s, tensions in the world were escalating. Nations teetered on the brink of war, and the discoveries of nuclear fission could not escape the attention of political leaders. Uranium was no longer a mineral for study. It was a strategic resource, a key to unprecedented power. In laboratories across Europe and North America, scientists worked feverishly, balancing the pursuit of knowledge with the urgency imposed by the shadow of global conflict. The energy within uranium, once a theoretical curiosity, now became a focal point of ambition, fear, and ethical dilemma. The Manhattan Project, launched in secret in 1942, epitomized this intersection of science, politics, and human ambition. Thousands of scientists, engineers, and laborers labored in isolated facilities from Los Alamos to Oak Ridge, driven by the urgency of war and the promise of harnessing uranium's energy. The element, once quiet and hidden in the mountains of Saxony, was transformed into a weapon of unimaginable force. Physicists calculated the precise conditions for a chain reaction, chemists refined uranium into fissile material, and engineers constructed the mechanisms that would unleash its energy. Every step was a delicate balance of precision and peril, a testament to both human ingenuity and the immense responsibility that accompanied it. July 16, 1945, marked a turning point in human history. In the deserts of New Mexico, the first atomic bomb was detonated. The explosion released energy equivalent to thousands of tons of conventional explosives, producing a blinding light, a towering mushroom cloud, and a shockwave that rippled across the landscape. The Earth itself seemed to shudder in response, as if acknowledging that a force once hidden in stone and soil had finally been unleashed. Scientists watched in awe and fear, understanding both the power they had harnessed and the responsibility it imposed. The atom, silent for billions of years, had spoken through human hands, and its message was both luminous and terrifying. Within weeks, the consequences of uranium's release became tragically clear. Hiroshima and Nagasaki bore witness to the devastating potential of nuclear energy in the wrong hands. Cities were obliterated in an instant, thousands of lives extinguished, countless others forever altered by the invisible radiation that followed. The world could no longer view uranium as a mere curiosity or a laboratory specimen. It had become a force that demanded attention, ethical reflection, and global responsibility. Humanity had learned that the pursuit of knowledge carries with it consequences far beyond the confines of science. Yet, the story of uranium's consequences was not limited to destruction. The same energy that caused devastation also illuminated possibilities for progress. Nuclear reactors, developed in the decades following the war, demonstrated the potential to generate power on a scale previously unimaginable. Cities could be lit, industries powered, and the limits of energy production redefined. Uranium became both a source of illumination and a reminder of restraint. Its dual nature, as a harbinger of both creation and annihilation, encapsulated the paradox of human progress. Medicine, too, found applications in the energy of uranium. Radiation therapy, derived from the study of radioactive elements, allowed doctors to target tumors with precision, saving lives and offering hope where none existed before. Laboratories continued to explore its potential for scientific advancement, tracing its isotopes through experiments in chemistry, physics, and biology. Uranium, once hidden in the quiet earth, had become a cornerstone of modern science, a symbol of the immense power latent within nature itself. The geopolitical consequences of uranium were equally profound. The Cold War, an era defined by nuclear deterrence and the fear of mutually assured destruction, was born from humanity's ability to split the atom. Uranium's energy became the foundation of international strategy, diplomacy, and tension. The element that had once glittered quietly in European minds now shaped global politics, embodying both the promise of energy and the threat of annihilation. The world had been irrevocably changed, and the responsibility for that change rested squarely on human shoulders. The environmental consequences, too, became apparent. Mining uranium left scars on landscapes, and the radioactive byproducts of energy production and weapons testing introduced hazards that would persist for generations. Humanity's engagement with uranium was not just a story of discovery and invention, but also of stewardship, ethics, and the balance between immediate gain and long-term responsibility. Each experiment, each reactor, each detonation carried with it questions about sustainability, morality, and the cost of wielding such a force. Yet, even amid these consequences, the poetic wonder of uranium remained. The element, forged in the hearts of stars and buried in the earth for eons, had finally revealed itself to human eyes. It demonstrated that within the smallest particles of matter lay energies capable of shaping the destiny of civilizations. The duality of uranium, destructive and constructive, terrifying and illuminating, mirrored humanity itself. It was a reminder that progress is never neutral, that knowledge is never without consequence, and that the pursuit of discovery is inseparable from the responsibility to wield it wisely. The story of uranium, through the Manhattan Project and beyond, reveals the complex interplay between science, morality, and human ambition. Its energy has fueled the engines of civilization and illuminated the night sky with the promise of nuclear power. It has also cast long shadows of fear, destruction, and ethical dilemmas that persist into the modern age. Humanity has learned that the secrets of the atom are not mere curiosities, but profound forces that shape life, history, and the collective consciousness of our species. In reflecting on uranium's consequences, one sees both the brilliance and the peril of human curiosity. It is a mirror of our capacity to innovate, to transform, and to imagine possibilities beyond the limits of our immediate perception. At the same time, it warns of the dangers of ambition untethered from responsibility. Uranium's energy is not inherently good or evil, it simply exists. It is humanity's choices, our intentions, and our actions that determine whether this energy heals or harms, illuminates or destroys, creates or annihilates. The consequences of uranium are ongoing. The element continues to power cities, to enable medical breakthroughs, and to challenge political structures. It reminds humanity that knowledge is never neutral, that power carries with it responsibility, and that even the smallest mineral, silent for eons, can transform the world in ways both wondrous and terrifying. In every glowing rod of uranium, in every nuclear reaction, in every historical footprint, the story of its power and danger is written, a testament to the delicate balance between curiosity, ambition, and ethical reflection. The story of uranium is not merely a tale of discovery, experiments, or consequence. It is a story that spans billions of years, from the hearts of ancient stars to the laboratories of humankind, from the quiet mountains of Saxony to the deserts of New Mexico, from the glow of a mineral powder to the destructive brilliance of a nuclear explosion. Uranium teaches us that the universe carries secrets far older and more powerful than our species, that knowledge is both a gift and a responsibility, and that curiosity, when combined with wisdom, can illuminate even the darkest corners of existence. Humanity has always been driven by the desire to understand the unknown. We look up at the stars and wonder what forces govern their brilliance, what invisible threads connect the cosmos. Uranium, forged in the nuclear furnaces of exploding stars, is one such thread, a tangible connection between the infinite vastness of space and the finite world we inhabit. It reminds us that the Earth is not separate from the universe, but a part of it, and that the forces shaping our lives have existed long before we arrived and will persist long after we are gone. Yet uranium also reflects the duality of human ambition. Its energy has illuminated cities, driven scientific advancement, and treated countless diseases. At the same time, it has annihilated cities, altered the course of history, and forced humanity to confront the ethical dimensions of knowledge and power. The element does not choose. It does not discriminate between good and evil. Its power is absolute, impartial, and eternal. What matters is how we, as humans, choose to engage with it, whether we wield our understanding responsibly or allow curiosity and ambition to run unchecked. The lessons of uranium extend beyond science and politics. They touch the very essence of what it means to be human. We are explorers, dreamers, and thinkers, capable of tremendous ingenuity and vision. Yet we are also fallible, prone to fear, hubris, and destructive impulses. Uranium, in its brilliance and danger, mirrors this duality. It challenges us to reflect on our intentions, our morality, and the legacy we wish to leave. Each discovery, each technological advance, is a reflection of the choices we make, a testament to our capacity for both creation and destruction. There is a poetic symmetry in the journey of uranium. The element was born in cosmic cataclysms, shaped by forces beyond comprehension, yet found its way into human hands. It moved silently through the earth for billions of years, only to be recognized, studied, and harnessed by minds capable of curiosity and imagination. In this way, uranium serves as a metaphor for knowledge itself, patient, powerful, and indifferent, waiting for humans to awaken to its potential. Its story reminds us that the pursuit of understanding is not without consequence, and that every step forward carries both promise and peril. The reflection extends even further when we consider time itself. Uranium's radioactive decay is measured in millennia, a constant reminder of the slow, inexorable march of change. It teaches patience, humility, and perspective. The atom does not rush. Its energy is released according to the laws of nature, not the desires of humankind. In studying uranium, we are confronted with the enormity of time, the transience of civilizations, and the enduring presence of the natural world. It is a humbling lesson, a reminder that we are part of a vast continuum, and that our actions, however significant they may seem, exist within a framework far larger than ourselves. Uranium also inspires wonder. To think that a single mineral, once hidden in the earth, could contain energy equivalent to thousands of tons of explosives, that it could split the nucleus of an atom and release forces born in stars, is to witness the sublime. It is to understand that the universe is alive with energy, that matter itself is dynamic, and that the laws governing the cosmos are at once elegant and terrifying. This sense of wonder is not merely aesthetic. It is the foundation of science, the engine of discovery, and the wellspring of human creativity. Without curiosity and awe, uranium would have remained just a mineral. With them, it became a catalyst for a transformation of human understanding. But wonder alone is not enough. The story of uranium demands reflection, a deep consideration of morality, responsibility, and foresight. It calls on us to ask difficult questions. How should we wield the forces we discover? What is the ethical boundary between exploration and exploitation? How do we balance progress with caution, innovation with humility? These are not questions with easy answers, but they are questions that every generation must confront, especially when faced with powers as profound and consequential as those hidden within uranium. Ultimately, uranium is a teacher. It teaches patience, reminding us that the forces shaping our world operate on timescales far beyond human lifespans. It teaches responsibility, reminding us that knowledge without wisdom can lead to destruction. It teaches humility, reminding us that the Earth and the cosmos are older, vaster, and more powerful than we can fully comprehend. And it teaches wonder, reminding us that even the smallest pieces of matter can hold the secrets of stars and the potential to transform life itself. As we reflect on uranium's journey, from its cosmic birth to discovery by Klaproth, to the experiments of Becquerel and the Curies, to the split nucleus of Hahn and Meitner, and finally to the consequences of nuclear energy and weaponry, we see a narrative that is both scientific and deeply human. It is a story of curiosity and ambition, of knowledge and ethics, of power and restraint. It is a story that reminds us that the universe speaks not only in the language of stars and atoms, but also in the choices we make in response to its messages. In the quiet glow of a uranium rod, in the shadow of a mushroom cloud, in the flicker of a nuclear reactor, the story continues. It is a story of humanity grappling with forces larger than ourselves, of learning to harness power responsibly, and of understanding that every discovery carries the weight of consequence. Uranium, silent for billions of years, has become a voice urging us to balance curiosity with wisdom, ambition with caution, and knowledge with reflection. The ultimate reflection, then, is not just about uranium, but about humanity itself. It is about how we confront the unknown, how we engage with power, and how we shape the legacy of our species. Uranium is a mirror reflecting our brilliance and our flaws, our creativity and our destructiveness. It challenges us to rise to the occasion, to wield the forces we uncover with care, and to remember that in the dance of atoms and the sweep of cosmic time, we are both students and stewards. The universe has offered us this gift, this power, this knowledge. What we do with it defines not only the world we inhabit today, but the worlds we will leave for tomorrow. In the silent heart of uranium lies a lesson as vast as the cosmos itself, that the pursuit of understanding is a journey filled with wonder, responsibility, and consequence, and that every act of discovery is also an act of reflection. The atom, divided and harnessed, has spoken, and it asks us to listen.